Okay, so hi everyone. Today we're going to solve this problem, that is LeetCode 446, arithmetic slices to subsequences. And this is a hard problem and it's a very good problem. It covers a lot of concept of the topics that are considered as advanced topic in data structures and algorithm. So we are given an integer array nums, return the number of all the arithmetic subsequence of nums. Okay, so in the nums there will be subsequences that are considered as arithmetic subsequences, and we need to return the total number of arithmetic subsequences that are present in the array, or we can form in the nums array. So let's understand what is an arithmetic subsequence. So a sequence of number is called arithmetic if it consists of at least three elements. Okay, one condition is that we need at least three elements, and if the difference between any two consecutive element is the same, and which means their common difference should be consistent throughout. So for example, we have 1 3 5 7 9, and this is going to have a common difference of 2, and you can observe that this is consistent. And for example, and we also have 7 7 7, this has a common difference of 0 and it is consistent. And similarly we have a common difference of -4 here, and this is consistent. These are arithmetic subsequences. And also because and it is also a subsequence because their lengths, each of their length is greater than or equal to 3. But this subsequence is not an arithmetic subsequence. Why? Because the common difference is not consistent. At this position it is 0, and at this position it is 1, which should not be the case, right? So this is not a valid arithmetic, or this is not even an arithmetic sequence. Now, a subsequence of an array is considered is a sequence that can be formed by removing some elements, possibly none, of the array. So for example, 2 5 10 is a subsequence of 1 2 1 2 4 1 5 10. So I think that you must be well versed with what is a subsequence of an array, because this is a hard problem and it requires these type of understanding. So if you are not comfortable with what is a subsequence and what are these basic terminologies like arithmetic and common difference, then I will recommend you to research these topics and then come back to this video. So now let's dry run this case. So we have 2 4 6 8 and 10. So we have 2 4 6 8 and 10. Their indexes are 0 1 2 3 and 4. Now let's take these subsequence. Let's start with 2. Can I take 4? Yes, I can. The common difference will be 2. Now can I take 6? Yes, I can. The common difference will be 2. So I have 2 4 and 6. This is one subsequence. Then I have 2 4 6 and 8. This is another subsequence, right? And you can see that this is satisfying the arithmetic condition as well, arithmetic subsequence condition as well. Then I have 2 4 6 8 and 10. This is another subsequence. Then I have so after these values, I will not start from 2 because I have exhausted all the values. Now I will start from 4. So we have 4 6 8. Okay, fine, another subsequence. Then we have 4 6 8 and 10, another subsequence. And now I will start from 6. So we have 6 8 and 10, another subsequent. And at last you can observe that there is a sequence, that is 2 6 and 10, right? The common difference on this side is 4, and the common difference on this side is also 4, which is why this is a valid arithmetic subsequence, because it has length n and the consistent common difference. Now the total number of subsequence that I found are 7, which is our answer, right? Which is our answer. Now one way of solving it would be to use the non-pick and pick and non-pick algorithm. We can use it, but it's not a very efficient one. And it is also an overkill, because it will give you a time complexity of 2 raised to the power n, and it's a more like a backtracking problem, and we won't be able to optimize it with the DP, because we will be basically printing these or storing these, or keeping a check on these sequences, and which could be a very hefty job. So instead of going with this algorithm, what I will say is, let's see another recursive algorithm which is very which kind of makes sense, especially with these test cases. So let me erase this one. Yeah, so now I will initialize my AP with these two characters first. I will say 2 4. This is my initialized AP. Now I can go to these index, that is 2. I can go to third index, or I can go to fourth index. If I go to 2 index, second index, Then I have the element as 6. The last element is 4. The incoming element is 6. And the common difference of these two elements, that is 2 and 4, is 2, which means that the new common difference should be maintained, right? The new element with the coming of new element, the common difference should be maintained. Otherwise, if it is not maintained, then it's not an arithmetic subsequence. So this is 2, this is 4, and then we are having 6. And 4 and 6 will give you a difference of 2, and this is the difference, the required difference. So yes, we can have it. So I will say 1 plus of, why we are adding 1? Because we are getting one new subsequence with it. And then we are going to solve it recursively for, now this is a recursive problem that I have, and I'm going to solve for it. How many subsequence are there in this subsequence? So we are going to be left with, now we cannot have 2, because we have used the second index element. Now we have the options of 3 and 4. Now can I take 3? With 3 we are having 8. So 6 and 8 will give you a difference of 2, and the common difference is 2. Yes, we can have 8. So 1 plus 2, 4, 6 and 8, right? And then I'm going to solve this recursively for another variation, and that is 1 plus 2, 4, 6, 8 and 10, right? And this will give, because now we cannot solve it for any further because we don't have any other element, any remaining element. So we will return 0 in this case. So it will be basically 0. So 0 plus 1 is 1. So this will be 1. 1 plus 1, 2. This will be 2. And 1 plus 2 is 3. Which means that starting from, and mind it, if we are going to choose 3, then it's 8. So 4 and 8 will give you the common difference of 4, but we are not looking for 4, we are looking for 2. So this won't be considered. And similarly, this won't also be considered. So with 4, you have total of 3 subsequences. What are those subsequences? So we have 2, 4, 6, then we have 2, 4, 6, 8, then we have 2, 4, 6, 10, or let's say 8 and 10, my bad. So it's 8 and 10, right? These are the 3 subsequences that I will get with the initialized two numbers, that is with the initialized AP with 2 and 4. Similarly with now we will move our J pointer. So I pointer was in this, now J pointer is in this, and with 2, 6 I will store the new element, that is 10, and now I cannot store any other element. So this is another sequence that I will get, and I will keep a check that if I'm getting a sequence or not, right? So this is one approach, and let's first write the recursive approach, and then I will give you, and then we will optimize it with the memoization. So first, we are going to store the size of the array. Sorry. So we have nums.size, and then we have int answer, that is initialized with 0, and then we have long common difference, that is also initialized with 0. Now I will iterate over the array. So I've told you that there is an ith element. The first like in initializing an AP, there's an I element, there's a J element, because from these elements we can have the common difference. And then we will have J is equal to I plus 1, J is less than N, and J plus plus. So first thing first, we are going to calculate the common difference. So common difference is going to be long. And why I'm taking long? So because we have this data type of 2 raised to the power 31 minus 1. So this is nothing but an int max, which means that we can have an int min and int max. So let's say we have a min value here, and then we have a max value here, right? So 0th index, second index, and then we have a third index. Now at this point, the min is now the common difference. Common difference will be maximum minus of minimum. And what is the minimum value? If you know that int minimum is nothing but the negated value of int maximum. So it will be maximum minus of maximum, and it will give you 2 of maximum. Now this is an integer overflow case. So in order to deal with it, we are going to use long data type. Yes, so it will be nums of j minus of nums of I, right? So this is the common difference that we'll get. Now after that, I will say answer plus the solve function that I was talking about. So nums. Now we have the last element. So last element is j, right? And the current element that I will have is j plus 1th element, and the common difference. The common difference should be sent in the array as an argument, because we need to keep a check. and then we will simply have our answer and we'll return the answer. Now int solve. So we have vector of int nums, and then we have the previous index, right? And then we have the current index. So you can ask that why we are using indexes rather than the element, because there can be duplicate elements and we don't want that collision. So in order to maintain the anonymity of the numbers, and so basically not anonymity, integrity of the numbers, we'll be using their indexes rather than their values. So the current index, and then we have common difference, so int cd as for common difference. Now if the current index is equal to nums dot size, then return 0, because we don't have any subsequence or element left in order to join with the subsequence, so return 0. Otherwise, now so now we will have total subsequence value, that is 0, and we also need we need to check the difference of incoming element. So for that I'll be initialize the variable with diff. Now we'll be starting with I is equal to current index, I is less than n, I plus plus, right? So I'll be calculating a diff value, and diff value is equal to long nums of, so now the previous value, so this is previous index, sorry, this is not previous, this should be I, because this is the incoming element, and it should be subtracted with the previous element in order to get the common difference or the difference between these two numbers, and that is the previous index. So when we have these values, then I will check if the difference that I have got with the adding new element is equal to the common difference. Then then it's a good thing. Then total sub is plus equal to 1, as I have told you earlier, that 1 plus of solve for this string which is now having that element, so that will be solve for. So if this string have this element, the previous index element is now going to be the current index element. So for example, nums, now previous index is going to be current index, and the next index will be current index plus 1, right? I think it perfectly makes sense. And then we have common difference, and now we will be returning this value, that is returned this total subsequence value. Let's run this function. Okay, this should be nums dot size, because we don't have a variable in this scope, n variable for this function scope. Okay, so we are getting a wrong value here. Okay, so let's see what is the possible issue. So this is the so the current value is I, and this is I plus 1, right? Because the previous value will be, now it's working fine. And but this is a very unoptimized function, because this function will take n square time, and this function will easily take, and there are overlapping problems, n square time, so it is n raised to the power 4 time, which is not something we want for this algorithm, even though we are given that 10 raised to the power 3 is the case, which means that we can have maximum of 10 raised to the power 4 algorithm. We cannot have 10 raised to the power 3 or 10 raised to the power 4 algorithm, right? We can have the algorithm with the time complexity as 10 raised to the power, n raised to the power of 2, n square algorithm, but this is n raised to the power 4, so this is not valid. Now let's optimize it. So in order to optimize it, I will say unordered. So before optimizing it, there are few variables that are changing their values. So the first is, for every common difference, we will have an index value, that is the end index value, and it will have a value that is how many subsequents are there. So for example, we have 2 4, right? 2 4, which means the common difference is 2, and let's say we are talking about at this position. So at this position, yeah, so 2 4, and we are talking about at this position. So how many subsequence do I have? So at position 3, the subsequence that I have are 2, right, from this function. So this is 1, it will be, yeah, yes, so it will have two subsequences. And what are those subsequences? So we have 2 4 6, and we have 2 4 6 8, right? These are the number of subsequences that I will get. Okay, 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 I need to clean this up because I'm getting confused myself with all this information which is not really relevant of when we are proving the memorization part. So yeah, at this point, right, you made a claim that with the two common difference, and when we have this let's say ending at 2, right, the total number of subsequence that you get were these values, right, which is 3. And why do we have 3 value here? Okay, yeah, so subsequence is calculated at this point. So I will say that 2 raised to the, so 2 common difference, and 1 is the index. No, no, sorry, not 1. 2 is the index. Then I will say that the maximum subarrays that I can get from this part to the nth indexes, including the nth indexes, will be equal to 3. And how is it so? So we have 2 4 6, we have 2 4 6 8, and we have 2 4 6 8 and 10. These are 3 subsequences that I can get, right? Now let's say that we have 4 6. We are initializing this AP with 4 and 6 this time, and I can keep 3, and with this 3 I will have the function as, yes. So at this part, when I'm keeping this value and I'm making an assumption that if it is there or not, so we have 2 raised to the power 2, and this is 2 with the index 2. So this is the value, that is 3 is 3, and at 2 raised to the power, sorry, not raised to the power 2, and another index is 3, we have the number of subsequence equal to, so this is 1, this is 1, 2, and at 2 raised to and 2 with 4 have the sequences as 1, right? Now let's see what do we mean by that. So similarly, when we are using this function, I say that this is 4 and I'm picking the third index element. So I will say that 1, and yes, I can have the third index element, fine. So the function it will call is the current index will be third, or the common difference is first 2, and the current index is third. I don't need to calculate this function again. Why? Because I have memoized this value, and this value is equal to 2, but now this value is going to be changed to 3, which means that s of 2 comma 3, which was initially 2, is now changed to 3. And why it is changed to 3? Because when s is from 2 to third index, the number of subsequence that it had were 2 4 6 2 4 6 8, but now there's another new subsequence that it got, and that is 4 6 and 8, right? This is the memoization part. We don't need to calculate these values and these values again because there was an overlap, so we can definitely memorize these values and use these values to our convenience. So let's memorize it. So for memorization part, I will say unordered map, and it will have a long value. Why? Because the first key value is the common difference, and I have told you earlier that common difference is something, is the data type which needs to be careful of, and it has to be long. And then we have an unordered map of int and int, and this is, let's say, dp, right? We are passing dp as an argument, and we are taking dp as an argument here. Fine. Now next part is to use the memoization value. For that I will say that if dp of, so if first of all we need to find the value, so if cd exists, right, dp dot end, and if cd is there, then at this cd we find that if the current index exists, if this is the case, if we have that value, then I will simply return the cd and current index value. Otherwise I will store that value. So this is cd and this is current index, right? This is equal to the total subpart. Now, okay, so let's see. Okay, we need to pass dp parameter here as well. Okay, now there's something very interesting which I have, which I have spent a lot of time understanding was that this value, that this function is going to be n square, right, which I've told you earlier, but this function is not going to be n square. Now this is not even n cube, this is n square. You know how? Because only in the first iteration we are going to have these values of different cd. After that we will be basically just adding the values. If we find a new element, if we find a new subsequence, then we'll just adding it into the value, the previous value, right? In this case you are basically doing n square work with a lot more constant, let's just say that, and there's a lot more constant, but still it is passed by the OJ and it will get accepted if you are not using C++. Unfortunately in C++ it's an issue. Why? Because we are not hashing, first of all, right? We are not hashing. This is a default hashing that is taking place, and there are a lot of collisions, because you can read about the unordered hash map, and we are definitely not going to use the map because it will take log n time, and we definitely want to use hash map. But hash map will pose a problem, and the problem is collisions. There are going to be a lot of values that are common, a lot of cds that will be common, and while making their hashes, a lot of values will be common. So this is definitely not the case, right? Even if you want me to submit it, then I can show you that this will, I mean, if you are not using C++, then in any other language it will get accepted, but in C++ it's going to give you a problem. Okay. Yeah, I think now this test case will run, but the values where we have a lot of numbers. Okay, it's not running again. What is the issue? So we have long. Okay, I think this should be long. Yes, but I know that, I know the result, it will fail. Yeah, I told you it will fail, and apparently only 2 test cases were left to solve. So I think this is the second last test case. Now I have processed this test case, and I'm going to paste this code in C++, in my editor, and I'm going to show you how much time it is taking on my local machine. And main, and we have solution S, then we have vector of int nums, int a, while c in a pushback nums, and then I will call this function. Fine. Now this is the test case which was giving us this problem. Now let's run this test case and see with DP how much time this is taking. Well, a lot of time. So it says timed out. We can try something else, and that is right. So now you can see that this is not performing anywhere close what we wanted. Why is it so? Because there are a lot of collisions, which is like not a very preferable thing. So let's try to hash it. Like I will say that, so we have a pair of long and int and then int, right? This will change for this value as well. Yes, here, and this is DP, and we need to create a hasher for this. So a hasher will be a structure hasher, and we have a template. So I will be basically creating a template of class T and class, because it's a pair, T, and then we have a size T operator. Yeah, thank you GitHub Copilot. So yeah, this is the value that I'm looking for, and this is T1 and this is T2. We can have T as well, because if it is pair of int and int, but it is not, so it's a long and int variable, so we need to have different template types, data types of template. And this is also T1, this is T2, and now we will have this hash, and the hash will basically be, so the hash will basically be the XOR of each other, right? Yeah, but there is a problem. Like if h1 is equal to h2, then yeah, if it is equal to, then we just simply return h1. We don't want to have 0 as a hash. So yeah, so this is the hasher that we have created, and we will be using this hasher with it, and we'll be using it here as well, and changing how we are using DP, how we are storing the key value pair in DP. We obviously have to change this type as well. So this will be commented out, and similarly at this place it will be dp of uh, cd, that is a common difference, and current index. Okay, so even after doing hashing, yeah, I think this is it. Like you can see that even if we are creating a hasher, it still have a lot of collisions, which is why specifically in C++ it will not work. But if you are using any other language like Java or Python, I think this approach will work fine. Although you will have like a very high time not the high time complexity, but the time consumption. Like I think in Java you will have like above 1000 millisecond if you use this approach. But we don't want to do this, and but we don't, obviously we want to get this problem accepted. So for that, uh, uh, yeah, actually I'm trying to have some time over here. Like if I can see that if okay this much amount of time it is taking, yeah, it would have been better. Okay, so one thing we can try is instead of passing it dp here, let's have dp this side. Okay, man, whatever. So this is it, that we can see that it's not working, and we won't be settling on it because we want it to work, right? So yeah, let's see how we can get this to work. So now I made an assumption. I made some, when I was doing this top down approach and I found out that I'm getting multiple TLEs and my solution is not getting accepted. Even though if I do the same algorithm, the same steps, and the same, hashing of using the same data structure, that is hash map, in Java, it is getting accepted, but not in C++. Then I, then I just given up on the uh, top down part and I moved to the bottom up. And at bottom up it was very fairly simple, and then at while doing the bottom up I realized that there are collisions in the top down using the DP data structure, that is a hashing, which is why it's not possible to submit the top-down approach in C++. So because of that, I will give you an example. So we have 2, 4, 6, 8 and 10, right? So these are the values. Now let's say we are starting, we have I index here. Now when we have I index here, I'm going to look for all the elements on the left side of the I and check if there's any valid AP. So this is 2 and this is so this is 4, this is 2. The common difference will be 2. And the element, and do I have any element here? No. So I will say that this is 1 AP, right? Because I've told you earlier that for to be an AP, it should have 1 or 2 elements so that there's a common difference. But this is not an arithmetic subsequence which is required by the problem, but it is still an AP. So I will say there's 1 AP, and then I will move this pointer to this value, and I will say that 4. So 6 will be compared with all the elements on the left side, and that is 6 is compared with 4. So it's the difference of 2. And we also have with 2 we have 1 AP here. With 2 common difference we have 1 AP. With 4, and we have 2, we have 1 plus 1, that is 2 APs with 2 common difference with 6 and 4, right? I think it makes perfect sense, which is why this is going to have. So what do we mean by that? That 4 has a 2 comma 1. So this is 2 common difference and 1 AP, the number of APs. So this means that 2 and 4, right? So what do we mean by 2 comma 2? So 6 is having, let's say 2 comma 2. This means that 2, 4 and 6, right? These are the APs that I can get at this position. Now I can make a, so this is not like a number of APs, but number of AP, but this is more like a length of AP. So this is of 1 length, this is of 2 length, right? At this point it's of 2 length. But if I have to calculate, I won't be calculating of 1 length, right? Because this is not a valid arithmetic subsequence defined by the problem. But if I calculate with 2 length, yes, I can calculate this subsequence, because it will be 2, 4 and 6, and it is an AP which has the consistent common difference, and it has a length that is greater than or equal to 3. So yeah, I can count this. And with so now 6 was compared with 4, and now we going to compare 6 with 2. So if we compare 6 with 2, we have 4, and there is no so the length of the AP will be 2 and 6, so it will be 1, and that's it. Now we are at 8, so I pointer moves to 8. We are going to compare it with 6, so we have 2 difference, and we are having 2 with so 2 number of, so the length of the AP is 2 with 6. So within the new element, the length of the AP will be incremented by 1, and that is 3. And at this point, yeah, so at this point, so 8 and 4, they have a difference of 4, and the AP, the previous AP, the length of the, and the previous AP length is 0, so it will be 4 comma 1, right? Now we have 8 and 2, the common difference will be 6, and there is no same common difference AP present, so it will be initialized with length 1. And at 10 we have 2 difference with 8, and it will be 4, because 1 element is added in the 3. And then we have then we have a difference of 10 with 6 as 4, and it will have the value at incremented by 1, because we are adding new element, that is 10. And at 10 and 4, the value will be 6, the common difference will be 6, and we don't have any same common difference AP available, so it will be initialized with 1. And at 10 and 2, the common difference value will be 8, and we don't have any AP initialized with 8 common difference, so we'll initialize with 1, right? Now at every AP, so I will say that if the length is greater than or equal to 2, then it's a valid AP and I can count it. So I will say that at this point I have got 2 APs, which means count 2. And at this point I have got, so not count 2, I will count 1 only, right? Because with length 2, there's only 1 AP. And then at this point I will also count 1. and at this point I will count 1. Yeah, count 1, and at this point I will also count 1, and at this point I will also count 1, right? Now, okay, so there's a mistake that we are not going to count 1, we are going to count their length minus 1. So at 2 we have 1 AP, right? Because the length is going to be, so these are the numbers, and this means there's one subsequence, so I will count it as 1. And at 3 the length will be like this, right? So there are 4 elements, so this can be the one subsequence and this can be the other subsequence, right? So we will count 2. And at 4 we are going to count it as, so there are 5 numbers, and these 5 numbers could be arranged as, this is one subsequence, this is another subsequence, this is another subsequence, and there will be 3 subsequences, right? And similarly for this 4 and 2 there will be 3 elements with the common difference of 4, and this is one subsequence that we'll get out of it. So it will be equal to 2 plus 3, 5 plus 6, and 7. So 7 is the answer and we are getting it. So let's code it out. Let's reset this part. And now we have our answer initialized with 0, and then we have long common difference as 0. Yeah, then we have a vector, because in order to store these key and value pairs as a, for every element there can be multiple key value pairs, so we need a vector of unordered map of long. So the first value will be the common difference, and then we have int, and yes, and this will be equal to dp nums dot size. Now let's start the dp. So we are not going to start with the 0th index, because we know that there is no processing that we will be doing here, because at ith index we are checking the left elements. At 0th index there are no left elements, so we don't need to check it. So we can start with I plus 1, I is equal to 1, and I is less than n, where n is equal to nums dot size and I plus plus. And now I will start this loop from 0 all the way till I minus 1, and I will check all those indexes. Fine. So I will have a value of common difference, and that will be a long nums of j minus of long nums of I. So this will be the common difference. Now there are two conditions, as I've told you earlier in the video, that there is a possibility that the common difference is let's say 2 of int max. But if there is a common difference of 2 of int max, that means minimum, maximum, right? So the common difference will be 2 of int max, right? So the next element, what will be the next element? The next element will be 3 of int max. So the next element will be 3 multiplied by max. But this is not true. This is out of the bound, which means that if we have a difference, if we have a common difference of greater than int greater than maximum or smaller than minimum, then it will never form 3 elements in the arithmetic subsequence. It will only have 2 elements, and 2 elements is not a valid case. So we are going to directly discard if there is a case where the common difference is greater than int max or the common difference is lesser than or equal to int min, right? In that case, we don't need to process anything and we'll say continue with the loop. Other than that, we are going to have the count of the previous arithmetic or the current, while we are scanning the length of the AP, we are getting their value, right? So dp of j dot find, and I will find the common difference. So if it is equal to dp of j dot end, that it doesn't exist there, then I will say 0, because if it is not there, then just simply return 0. Otherwise, if it does exist, then dp of j common difference, we will have it, and this is going to be my answer as count. And dp of ith current, because ith is the current value, the current numbers for whom we are calculating this count variable, calculating the value of number of subsequences or the length of the subsequence that we'll have with the common difference, with the associated common difference, and that will be equal to dp of common difference of ith value is going to be equal to, so this is, yeah, I think I'm just tired now. So this is equal to plus equal to count plus 1, right? Okay, so at this point it's j find, yeah, and then we will simply return the answer value. Okay, so yeah, it should be decreasing. No, it should be increasing. Okay, so this is j, not I. Jesus. Yeah, it's working fine. Let's submit it. And yes, it's getting submitted. Okay. So you can see that there are a lot of worst, very bad performing solutions. Okay. Yeah, so this was the one that I was doing, right? This is just a bottom approach of the one that I was doing, and this is the same thing. Like, it is getting selected because it's not a recursive solution; it's a bottom up one, and they are using vector of map. Actually, it's different than mine. It only has this similarity that we are initializing the subsequence with 2 elements. Yeah, so anyways, very very cool problem. I think I will be creating another video on this after few weeks as a revision. So yeah, this was it. The time complexity of this solution is easily n square. You can easily observe this is an n square time complexity, and the space complexity will also be the space complexity will be, I think, depending on the common difference, the unique common differences, and n value, right? So n into unique common differences values, so n cd into n, which is also equal to, like, on an average, n square. So yeah, so that is it, guys. Thanks for watching.